All right, welcome to Vegas Programmers Monthly Meetup. I'm Joshua Copeland. I've been running the Vegas Programmers Meetup for a little over 7 years now. Even through the pandemic, I was running the virtual meetups and stuff, and when Tech Alley started here about 3 years ago, I jumped on the opportunity because what a better place to network, meet other like-minded individuals, and share knowledge, which is my number one thing. When I was in college, there was no local programmers meetup, and how I would have loved to have the ability to share information, meet others, and bounce ideas off of people, because I feel like one of the worst things is working in a siloed environment where it's just you, and working off the shoulder of giants and being in a room of people who are smarter than you is always my goal here. So thank you everybody for coming out. We have two very special talks lined up for you. We have basically two people coming into town for the React conference, and they were nice enough to offer to volunteer to speak about some things related to React, JavaScript, all that kind of stuff. So who's going first? Travis, you going first? Yeah, okay. So Travis Draper, he's going to be doing a talk on Don't Be Afraid to Upgrade, a React 19 exploration. So that's going to cover basically React, its new release, what to expect, and things like that. Then we have David Nicholas, who's going to be talking about unleashing conditional types. So if you've worked with TypeScript in the JavaScript world, that should be super informational on, all the things that you need to think about when dealing with typing in JavaScript, right? So before we get started, just a couple of things. So first off, thanks to Vegas Theater Company for hosting us. I always appreciate the space. Every time I come here, it's always a different environment. One time we were on the surface of Mars. Now we're in Abu Ghraib, I guess. I'm not sure. But yeah, and also thanks to Tech Alley, obviously. Awesome, network. How awesome is it to have back-to-back meetups you can go to, right? Back in the day, we used to be at the Switch building, and there would be like 10 meetups all happening at the same time. You got to pick one, and then that was it. And then that was the end of the day. With this, it's just a great format. So thanks to Joshua Levitt, James Roop, all the people, Ryan, who step up and help support this community. We will have a free 1-year JetBrains license to give out. If you've ever used an IDE before, you need a license, reach out to me. I have a few to give away. And also corporate co-working. Thanks to them, if you need a spot to work here locally in town, they're near the Allegiant Stadium. Beautiful co-working space. So tell them that we sent you, and you get a special discount if you just need a day, or if you need a whole package and want to work there full time. So thank you, and I guess without further ado, Travis. Yeah,
thanks.
Yeah. I'm gonna clip you up here.
Oh, yeah.
Use this if you want.
Cool. Test. No, maybe. Use the mic. Oh, I see. Sure. Gotcha. Also, fortunately, my voice projects pretty well, so this might not be super necessary. Anyway, hello everybody. Yeah, as Joshua said, my name is Travis Draper. Yeah, hello. Thank you. And today I'll be doing a talk on React 19, which was obviously the hot topic at React Conf this past Wednesday, Thursday over in Hendersonville. I've never been over in this region of the country before. And I'm going to be talking about the new APIs that have come online with it and everything, as well as the direction that React is going that is suggested both by their conference speakers from Meta, as well as the documentation for this new version release. And then I have a couple of simple demos that I'll walk y'all through to both showcase some of the new APIs, look at what it would look like, and how, frankly, easy it is to refactor from React 18 code to some React 19 code, and a little bit about what's going on under the hood when we talk about React server components and server-side rendering, which is the juicy bit going on right now. So without further ado, that's me, as I said, formally introduce myself. I'm Travis Draper. I'm a developer and a consultant. Bitovi is actually the consultancy I work at, and that is the only bit of plugging I will do for them during this entire talk. Don't worry. I'm a JavaScript developer, basically exclusively specializing in React and React Native. And for the most part, for the last 2 years, I've been almost exclusively doing React Native work, which was great because React Conf was a lot about React Native, and there's a lot of cool stuff coming. And if you want to hear more specifically about React Native, find me after my talk. I like cocktails over beer. If there was time and you asked me to get a beer, I'd say yeah, and I'd drink a cocktail because I think they're yummier. And lastly, I'm a Sour Patch watermelon enthusiast. I like gummies, and I feel like Sour Patch watermelons have the right mix of sour and sweet. Any questions about why Sour Patch watermelons are the most superior candy? Good, that was rhetorical. All right, let's get it going. So the agenda. We're going to start by just kind of talking about some key takeaways from React 19 Conf. I'll tell y'all where I think the vision of React is going with 19. And then we're going to move into talking about specifically the release notes, specifically starting with SSR and CSR, kind of a quick breakdown of what that is, depending on the level of familiarity of the audience. I have a kind of a simple demo to showcase with that. We'll move forward to use optimistic and use deferred value, which are new API hooks or updates to pre-existing API hooks from 18, as well as React Actions and React Form, and the use API. And again, you'll see all of these together in a demo, so you'll get to see practically what it looks like and what it takes to implement. And then lastly, some notable mentions, because the docs are fairly extensive in terms of what React 19 is releasing. In my opinion, React 19 is kind of the biggest release React has had since hooks. Like my colleague who will be speaking after me, he and I have sort of differing opinions of the impact of this release and how exciting it is. And it depends upon the perspective you take, and we'll get into that in just a moment. But for me, I think either way you cut it, it's a fairly consequential and meaty release for React 19. So let's get into it, yeah? And I'll stop here and there for questions, but I will say this is a fairly packed presentation, so I will try to move ahead, but I'll do my best to check in with y'all too, okay? Let's do it! So, React 19 key takeaways. As I've kind of already rambled off here and there, the biggest things about React 19, you know what, I'm gonna kind of like pace the stage a little bit, because that feels more natural, because there's not much going on here right now. The biggest takeaways from React 19, in my opinion, are gonna be the SSR capabilities. And they're going to be basically the SSR capabilities and first-class support for more async operations. And we'll get more into what that means and looks like shortly. But beforehand, React 18 and before, it's a front-end library. It's still a front-end library, don't worry. But it's a front-end library that has gotten taken up by meta frameworks like Next and like Remix. And they've used React as the foundation to create really exciting opportunities for developers when it comes to blending server-side and client-side logic. We got progressive enhancements, server-side rendered components, hoisted metadata, things like that. And React couldn't do any of that on its own. And to be fair, it was a front-end UI library, so there was no reason it really had to. But with React 19, it has now released the ability to do so with sort of vanilla or pure React more easily than ever before, which will ultimately impact how we choose to pattern our React code. And I think that's another key takeaway from this conference, is as React 19 goes from beta to full production release and developers become familiar with it in their code bases, there will be a meaningful, but not like hooks level crazy, shift in how we pattern our component logic. And you'll see an example of one of those components shortly. And then the last thing I want to say about the key takeaways, again, like I said, my colleague and I differ on our levels of excitement from React 19 Conf. If you consider React 19 as an element in the ecosystem of JavaScript, it's not crazy what's come out with this release, right? Because the meta frameworks like Next or Remix or libraries like TanStack Query and things like that are already doing the things that React 19 unlocks out of the box with first-class support. But if you consider from 18 to 19, it's big, and it just also, again, promises the direction of where React 19 is heading. Any questions so far? Am I talking too fast? I did have coffee. We'll see if that was a mistake. All right, so let's get into it. And also, now that I'm going to be down here when I do this demo in a minute, hopefully that's okay. And we'll see how that goes.
I guess I have one question.
What's up?
Maybe you can answer this as we kind of go along.
Sweet.
What does these new advancements do to Next, right?
Yeah, great question. I can actually kind of answer that up front. Okay. Not much. Because Next already had this capability baked in with React, because they are a full stack framework, they already had the back end and the front end to play with as their playground, whereas React has been a front end UI kit. I say kit, library. I feel like kit's a little misleading. And this release for React 18 to 19 is kind of like a catch-up release. Not like the condiment, but like I caught a ball catch-up. They're getting first-class support for a lot of things that Next or Remix already do. But in terms of thinking about what the meta frameworks will do next, next, I'm sure that happens all the time and everyone groans at this point. Next built the features that it has with SSR, SSG, progressive enhancements and all these capabilities off the back of React before React had any first-class support for that. So what are they going to do next now that React has made it easier to do those things out of the box? Right. So it kind of just makes things exciting, but it's a question mark. Yeah. So how many people here are familiar with server-side rendering? Can I get like a raise of hands? Of course, Mr. Next. Yes, you would be. Cool, cool, cool. I saw a few. And then how many people are familiar with what CSR client-side rendering is? Okay, cool, cool, cool. All right, so I'll give a very quick rundown of the difference between the two. But actually, before I do that, let me even take it a step back further. How many people here are familiar with React? Okay, cool. I got a majority of hands, which is good. So you're in the right place. So CSR, client-side rendering, is basically the bread and butter of React, what React was doing before 19 and still is capable of doing. That's going to be your SPA app, single-page application. You make a request to a server, you get back basically an empty HTML document, aside from the meta information, and then a div with an ID equals tag, or root. And then your JavaScript bundle loads in, and then it kind of uses functions to inject your HTML from there. That was the bread and butter of React all the way up until now, and it still continues to be, and that's called client-side rendering because the rendering happens on the client side. And then, unsurprisingly, SSR, server-side rendering, the rendering happens on the server side. And what that sort of might look like in the world of React is we have a component that renders, JSX. The server can go ahead and render the HTML that's outputted by that function because JSX is syntactic sugar, as everybody says. Brush your teeth. And create the HTML and then go ahead and send that to the client when it's requested. Or alternatively, there's SSR. If you consider SSR as an umbrella term, underneath that there's also static site generation SSG. It happens by default, by the way, with Next.js and their app router. I don't know if you've used that, Mr. Next, sir.
Indeed.
Nice. But with SSG, basically your sites, your HTML is generated at build time when you're deploying. So it doesn't need to be dynamically built when it's requested at runtime, which is kind of cool and can lead to some optimizations depending upon your use case. So that's CSR versus SSR. So React Server Components are the new thing with React 19. Dan Abramov gave a big keynote about them and everything like that. And basically what that means is you can now write components that can either be run on the server, or they can be rendered, or they can be rendered on the client. And the way that we do that is through a directive that exists at the top of the module, which you'll see in the example, use client or use server. And by default, apparently, it is use server. So if you try to break the rules of a server component, which I'll tell you in just a moment, React will yell at you, and you'll need to pop that use client directive at the top of your module. So with a server-side component, essentially, there's a few limitations. And if you don't break any of those limitations, you're writing a server component. And that's kind of how it's going to be treated. To be clear, by the way, out the box, you're not going to be able to use React server components, just like spinning up a V app with React. But things like Next, for example, are already integrated and able to use them, and the other meta frameworks will be coming online with them shortly. But if you try to just do a CRA sort of vibe, you might have a hard time. So, what was I saying? Right, so the limitations for React Server Components. It needs to be a pure function with unchanging props. What does that mean? Well, I guess that's pretty straightforward. There are no side effects happening in that component, which is to say there's no like stateful use states or use effects or anything like that being triggered in your component. The twist there, though, is you can now run asynchronous operations with await in your components. So for example, if you're writing a server component that's going to pull a list of users from a database, you could have, function list view equals, and then it has the whole component, constant users equals await database.connect, and then you pop it the query that you want. And it'll await that before it returns the HTML. And there's a couple of APIs React offers you, which we'll get into, that can make that even more convenient and more optimized. So also too, when I say it's pure functions with unchanging props, you can't pass a prop to a server-side component. With things like Next.js, for example, they've got some built-in integrations, like most meta frameworks will, where you can access the cookies or the query parameters, but I cannot have a component pass properties to a server component, because a fundamental thing to consider, or to always keep in mind as we're considering the kind of expansion of scope of concerns for React with now server-side components, is there's still two different worlds. There's the client world and there's the server world. We can play in both, but there are limitations and rules to how they can interact. Question? Oh, sorry, you're scratching your head.
I have a quick question.
Oh, who said that?
Yeah.
Yes, what's that?
What's the reason for having the server-side component at all?
Great question. So a lot of this comes down to optimizations, faster performance, getting that, there's the acronyms for like first paint, time till user click, interactability. All of these things make those times shrink, make them faster, make the apps feel more responsive and faster, and give to a better UX, which makes users happy and makes them more likely to visit the site more often. It's kind of the biggest one. Frankly, with server-side components, though, there's another fun factoid, which is you can make requests to your server-side resources like databases and things like that, and you won't accidentally spill your secrets because they're server-side. So it can make a better DevX too, and that way you don't have to do as much thinking about that. And then the other requirement is not in client fence. What do I mean by client fence? I mean a client component cannot render a server component, which is kind of what I was just talking about. Which, if you then extrapolate that, the primary use case that I think we'll see for server-side components is going to be like top-level components for a new page route, right? You might get, think about like a landing page or something, for example, that doesn't need a lot of stateful user data or anything like that. We can probably static site or server-side render the majority of that component, and then it might have stateful client component children. Any questions so far? Sweet. I'm proud of me for actually remembering checking. All right, I'm trying to keep going because I feel like the demos are going to be the most illustrative moment here. And then, as you asked, benefits for the speed. You can shrink your JS bundle size by doing server-side components, because those components are not going to be in your JavaScript bundle, because they're actually just outputted as raw HTML, which I'll showcase in the demo. And React is typically guilty of having a fairly large JavaScript bundle compared to other choices, and so the team is aware of that and they're working to fix that a little bit. Also, progressive enhancements, partial or full progressive enhancements, which will connect to like hydration and interactability for forms and things like that. They have some pretty cool stuff that I'll show you in a minute. And then also with server-side components, there's another opportunity to leverage an already existing React API, Suspense, and then a new one, Use, to create a more declarative, composable loading UI. I see a man laughing.
That's Suspense, definitely.
Yeah, right. What's that?
Years ago, when we used Next, it was because of SEO reasons. Is that still a factor nowadays, or as Google and these other web crawlers kind of come around to rendering the site before crawling for SEO?
Right. So Next is still a good opportunity for SEO. Also, here's a full disclosure. I'm a big Remix fan myself. I've used Next briefly, and also for the context of this demo. My colleague might know more about Next, so you can ask him after the talks. But with server-side rendering, for example, you're going to have your HTML, and if there's any SEO functionality that's involved there, it will be rendered, it will be crawled as expected, which is, I think, a nice gain. But also, we'll talk a little bit about how React is able to hoist up various metadata tags from functional components into the head of the document, which may or may not solve some of the SEO crawl problems, but we'll talk more about that. Cool? Sweet. All right, let's keep going. Okay, so we have declarative UI loading approaches, right? So you'll see 3 top-level bullet points: use optimistic, use deferred value, and suspense. Anyone that's used React recently is probably familiar with what suspense is. This man over here laughed at it. Haha. But then you also have use optimistic and use deferred value. Use deferred value actually came out in React 18, though I did not use it much myself. And then use optimistic is a purely new one. And the reason I kind of point them out as 3 different top-level bullet points within declarative UI loading approaches is because while they can be used in combination technically, they lead to different UXs, user experiences, based on how they're leveraged. And again, in the demo, you'll see these in actual application, and we can get into more detail. I will say sort of at broad strokes here, use optimistic will allow you to optimistically update your local stateful data while you're waiting in the background for an async action to complete, which, again, not something React supported out of the box before. You had to write your own sort of UI code. You'll see my disgusting attempt at that as a point of comparison pretty soon. Or you would use a third-party library like TanStack. Woo. I say woo because I love them. And then you have use deferred value. I think that's a great use case for get operations. If you want to show the previous data set while a new data set is out fetching, it'll basically defer updating the value until the async action completes, and it can render and return the new value. And then lastly, suspense, which, like I said, could be used for any of these, but this is sort of not really this is not an option probably where you're showing your state. At this point, you're sort of suspending up the component tree a bit to a loading fallback UI, if you've ever used its API, like a spinner or something after you do a submission. And we'll see these in practice fairly soon. Hey, actually, apologies, everybody. I got a little ahead of myself. Before we leave this one, I have the first of the 2 demos to show you about RSCs. Thank you for your patience as I go all over the place. Also, let me just say, I am aware this is not cute looking. Thank you for your patience. But the functionality is there for the talking points. So, here is a demonstration. This is going to be a demonstration about SSR and CSR and what that looks like in, not the console, but in the HTML. So what you're about to see when I click on this button is going to be 3 different loading states for 3 different components. One of those components is going to be a server-side rendered component that is suspended while it fetches an async operation within its file code, which I'll show you after you see the visual. And then another one is going to be a client-side component that handles a loading state, how we might React 18 with a loading, set loading use state, and a use effect to change the loading state once some operation has come back that we can confirm, which means multiple renders, multiple paints. And then the last one is going to be a client-side component that uses the new use API to also suspend using a server-side promise, which again you'll see in the code. So here's the admittedly ugly, but conversationally useful demo. So let's refresh and watch it again. So you'll see top one is the client component, middle one is the server component, bottom one is the client-side component using that new use API. All 3 of these show loading states until their requests, their async operations finish, and that's when they turn yellow. Initially they're blue. The blue is suspense or something suspense-like in the case of the client component that's just managing it via stateful loading flags. You'll see, for what it's worth, the server-side component comes back just a little bit faster. And then for what it's worth too, in the bottom one, the client component that uses the use API, that whole thing in outline is the component, but a portion of the component is still able to render while only the relevant subcomponent that depends on that promise suspends, for what it's worth. And then let's take a look really quick into the HTML. So React, we get a big JavaScript bundle like I talked about in the beginning. We're going to inject that into our HTML via React functions, JSX being sugar. What's up, sir?
So you have 2 components there. So the first one comes from the client side, the second one comes from the server side. The client side is actually expecting data from another server side. So it could be a middle-tier application.
The client, I missed the last bit of that. The client side is getting data from a server-side function.
Yeah, from some kind of middle-tier application, right?
Yes.
Technically, it's also getting from the server.
Yes, it is.
Okay.
Yeah. But the difference here is that this component comes in via the JavaScript bundle. It renders to the page, the use effect, and with a loading state set to true, the use effect, and then an async operation completes. And once the async operation completes, the loading state will get set to false in a promise chain, a .then, and then it'll lead to another paint. Whereas in the server-side component, it just comes in as the HTML.
Oh, okay.
Yeah, less literally less time to finish rendering and less bundle size. So good question, because I want to show y'all really quick what this looks like in the HTML, which is going to be, I think, right here. See this script tag right here? Hello? I can absolutely maybe make that bigger. Zoom in. That's not making that bigger. How do I make my console bigger?
Click on that and hit Command C, or Command plus.
Command, good call. Kudos to you, Joshua. So, right here, this is the output of the server component for this middle guy right here. This is not in the JavaScript bundle, and if we reload the page and watch, you'll see that script tag actually load in after the page is already finished. The reason it does that is because I've wrapped the server component in suspense, so it's able to stream in as it's finished. Had I not wrapped the server component, the middle one, in suspense, the page would have just waited for that server component to be done before giving me the HTML, so this whole page would have just had the experience of taking longer to load. But because we leveraged it with suspense, we get streaming possibilities there. Any questions so far? Some of that's already with suspense, but a little bit is RSC. Cool. But yeah, so that's what it looks like. The JSC payload, is the React team calls it. It's basically just a virtualization of the output of the component, and the React's like, hey, I know you're looking for this in the bundle. It's not there. Just put this there instead. Yeah, cool. Thank you all for letting me kind of like backtrack to make sure I actually gave you the full experience. And let's move on to actions. Reminder, we talked about declarative UI loading approaches. And then we're like actions. And now we're back where we were before. So this is from the actual React 19 docs. I think it's a really good explanation. By convention, functions that use async transitions are called actions. One thing to note, let me check time because I didn't start my timer. Joshua, keep me honest if you need to like cane me off stage at a certain point. Async transitions are called actions. Anyone here that's used React, have you used start transition from React 18? Yeah, me neither. Start transition is an API that was released with 18, which they talked about a lot at the conference. They're like, you now have had a lot of time to use start transition, right? Yes, absolutely, it's so great. And my colleague and I are like, what? It's basically, it's a function that'll allow the callback inside to batch any stateful updates and make them non-blocking and happen in the background, which is probably good for like animations in an animation library, or as I discovered as I was kind of researching it again today so I could actually talk about it better, if you have like a long running stateful update that needs to happen when you click on a UI element and the user decides they want to back out of that and they click it again, if you didn't wrap it in start transition, they'd have to wait for the thing to complete before it would then go back. But if you wrap it in start transition, it'll start its transition in the background, but then if another one comes in, it'll overwrite the previous one, which allows the user to sort of bail out in a sense. So with 19, however, start transitions, which could only formally be synchronous, can now be asynchronous, which is a big deal when it comes to doing server-side operations and background batched updates. And it's kind of under the hood how use optimistic works, and we'll talk about that. So server actions are yeah, that's fine. Server actions are another kind of action to talk about. They are actions that are generated on the server, that are generated in server files, because now with React, you can be writing modules that are server-side modules. And they can either be defined within server components, so that server component we were just talking about in the last demonstration, where it finished and then it streamed in. I can define a server action in there like I might have defined any function in a normal component beforehand. So, const test component equals, and then it has all of your logic and then your return at the bottom. I could define a function in there, and then at the very top of the scope of that function, pass it the use server directive to tell React that it is a server action, a server function. But that can only be done in a server component. You cannot define a server function in a client component, again, because two different worlds, that's not how the communication pathways work. Or they can be defined as like you might define any file in like a utilities folder, for example. On the server, you could do the use server directive at the top of the file. Those are all server functions. And when they render over in React, React creates a reference to the function without including its entire scope in the function call, so you avoid spilling secrets. And why are they useful? So, for example, as we talked about when we talked about awaiting functions directly in components, you can do the same thing, but you can define it as a function first, for example, and create logic communicating directly with backend resources like databases, and then pass those functions into your client components and have them be the submit actions for your forms, for example. So save yourself some extra boilerplate code and co-locate things, which frankly I love doing with my programs. The more I can co-locate my logic, the better. And then also progressive enhancements. Specifically when you use server actions with forms, you can get some really cool progressive enhancement stuff, which I know I keep saying I'm about to talk about that, but I think I talk about that in the next slide. And I'm moving through these because all of this is going to be discussed in more detail in this upcoming demo. Last one before we look at the demo, a hook for your forms. A little misleading, and I apologize. Use action state technically does not have to only be for forms, but it's really great for forms, and I'll tell you why in a moment. Use action state is a convenience hook that React provides to solve that use case where in your component you have a pending, or is pending, set is pending, error, set error, on submit, and then you pass that to your form and you listen to those stateful values to decide what to render. That's a very common pattern. React has now made this hook called use action state that exposes all of those states as the output of its hook in a tuple. It will background and batch your stateful updates using under the hood a start transition, which means when you submit an async action form submission, all of that logic will happen before any state updates happen. Which can be a problem, for example, if you're trying to set a loading state inside of the callback function, but I don't want to get too into the weeds until you see code. So, but keep a pin on that one. As I said, it's a great convenience wrapper to expose common stateful values that we use when we're doing form actions and things like that in form components and form logic. And then also when it's used with forms, you get support for partial or full progressive enhancement. What's really nice, I can speak to partial. With full progressive enhancement, it's a little grosser to explain. There's basically a third optional parameter you can pass to the hook called permalink, and it has very niche specific use case requirements. So I'm not going to really talk about it, but it's there if you want to try to figure it out. But what's really nice without that permalink option is if you pass an action to a form, and then you try to click the submit button on that form before the page is fully hydrated, before it's become fully interactable, React will replay that form submission once hydration is completed, which means the user won't lose that click, which is, I think, pretty cool, and you don't need to do any permalink stuff to make that work. But that's what happens when you link a server action to a form. And then also use form status. This is another convenience thing. If you have children components to a form component, mind you, not rendered in the same component that renders the form, so think about this like a context, but as children to that form, you can use the use form status hook to get back the pending status of the form, the most recent form data submission, the method of the form, whether it's a get or a post, for example, as well as a copy of the action. So your children components to a form can access the form state without having to write your own context or prop drill down, which is just a good quality of life one if you ask me. All right, so I think, yeah. All right, I can show y'all the kind of bigger demo, which might be enough time that I have, sorry. So I'm gonna go back. That's right, it's called the goodies because there's a lot of stuff in there I didn't know what else to call it. Thank you whoever said perfect. You're perfect. Ooh, I got a warning. A tree hydrated, but some attributes of the server. That's fine. Oh, actually, that's a really good, okay, hey, so this was unintentional, but we can use this as a good talking point too. One of the notable mentions I was gonna say for later is with React 19, they've done a much better job of deduping their hydration errors when it comes to server-side rendering. I don't know if you have any experience with that beforehand using Next or Remix potentially, but if there were third-party scripts or browser extensions in there, it was quite often that the server-side HTML was not going to match the client-side HTML, and you were going to get a hydration error sort of like this, but you get it multiple times, and it wouldn't really tell you where it was. And it was really useless, and it was really alarming, and it was really frustrating. But now, with React 19, they've deduped the number of warnings that are there, and when possible, boom, I love this. They provide the diff of the server-side versus the client-side HTML to help you locate faster where the error arose. And I always thought that was pretty clutch. So anyway, we can ignore that though, probably. Actually, we can. It just leads to an extra render. So what I want to show y'all with probably the last of my time, I'm sorry, Joshua, if I'm going over, and I am open to being vaudeville caned. Let's see the best way to explain this. Basically, what we got here is a really ugly looking, I know, container for a chat box, which will contain a list of typed messages, as well as a text input and a submit button to add a new message to that list. And I got a little toggle up here. This is displaying a new chat box, i.e. this component is written in React 19 APIs, and then this component is written like React 18 APIs. They will functionally look the same, but under the hood, they're implemented differently. And this one has less code. There's the hydration error. I know why it's happening, but it's not a big deal right now. Sorry for my mess. So let me show you the code before we get going. This isn't too important. This is the container for both of them. Do I need to show you? No, I don't really need to show you that. All right. So this is, actually, let's show you this one first. This is how this might have been written in React 18. So you've got, I wanted, well, can I make it big? You know I can, thank you.
Bigger or contrast?
That work?
Yeah.
Cool, sorry guys. So actually, before I show you the code, let me just show you the functionality. Test, enter, pending, test. Let me do one more, test one. So try to notice all the different stateful changes. You'll see a pending tag, you'll see loading on the submit button, and then it disappears and the value is there. So basically the functionality here is a loading state disables our button and changes it to is loading or please wait. And then we optimistically add to our local store the new data submission with a is pending tag so the user knows it hasn't submitted yet. This is how that might look in React 18. You got your optimistic messages, your set optimistic messages. We're having to hold that in local state so that we can optimistically update it. Technically, there are third-party libraries that can make this more convenient and hide it away under the hood. I'm just giving you a longhand approach to how this might look, out of the box, I mean. You got your is pending, set is pending for when you submit your form. Error, set error if there is an error, which actually, Oop, I typed it wrong, so it's not gonna work. One hand typing with caffeine. Oh my gosh. Boom. Error. There's your error state, for example. Set error, and then you have a controlled input, stateful controlled input text, set input text. And then you have your submit function. We're putting the default because we don't want the page to reload. If there's no input text, we had an error. How'd you submit this without an error? I know that's not the best way you'd want to handle that. Set is pending to true because we're about to start our operation. Add your optimistic message. Go ahead and clear out that input field. And now do your server post. Get your response, parse it, make sure the result's okay, clear the error. Revalidate's basically just going to refetch the list of messages from the server. And if that doesn't work, then throw a new error, catch it, set the error, and says pending false. Try catch finally. Woo-hoo. And then we have our onChange handler just to set the input text value because this is a controlled component. And then lastly, a use effect, which is basically to update our optimistic messages, which is what we're actually going to be rendering into the component, to match the data store whenever the data store is finally updated, which basically gets rid of that is pending flag. And those are all different paints, right? These all happen at different steps in the life cycle of the React component. And then here you go. And you'll even, I will point out one thing, we don't need to go into here, but I will point out that you have your onSubmit action, define the method, and then I will say I had to make a separate component, message form and input and submit old, so that I could showcase the prop drilling I have to do, the onChange, the is pending, the input text in order to get that button disabled, to control that input, and to pass down that action. And then here's how it looks in the new chat box. You'll see up here at the top, by the way, use client directive, which I have to specify because this is a client component because I'm using pieces of state like use ref and use optimistic. And if you don't, React will yell at you, and then you'll add it, and then React will be like, all right, I'm gonna stop for now, but I'm watching you. So you'll see here, I got a couple, let me actually show you really quick too. The total lines of code is 58 on Chatbox, and on Chatbox old it's 74. So you're cutting about 20 lines of code. But I think more importantly though is the legibility is a little bit easier. You're not having to depend on things like a use effect to track the life cycle of the component and have a fundamental understanding how that works, doing extra paints. So we got a form ref, which we're going to attach to our form. We have the optimistic, we have the messages and the set optimistic, and then here's the use optimistic hook, which I talked about before. It is a hook that takes a callback function. That callback function receives the current state as well as the incoming message that you want, that you pass to it, that you want to optimistically update with. So all I'm doing is just adding it to the list. And then you got error, and then here's where we got the bread and butter use action state. Technically, the tuple that's returned from from use action state is state, the action that you've passed to it that you can now then use and pass down to your form. And then also, I think, pending flag. I don't know why I didn't do pending flag here. Anyway, so oftentimes, and what I've been seeing in the docs and some other common implementations is that first tuple value, the state, that's going to be whatever returns from the callback function you pass to it, and typically that's going to be your error state. So I've gone ahead and named it error, and that's part of the reason React made this a tuple rather than an object you can destructure, is to make renaming things a little bit more convenient for your use case. So you'll see here, use action state, and I pass in this callback, and it is asynchronous, and it has a server action in there, server post, and I will do, get the form data, and I should say, the callback that you pass to this gets the current state of the form, if you need that for some reason, and then the form data submission when you click submit. So I get the message input that I want because this is the name of my input. If there's nothing there, I return error, and the way that this is working is that's my error state now. Otherwise, I clear the form, which clears that input. I set my optimistic message, which is going to run this callback and just append it to the end of that list. And then I do my server action. I parse my result, and if it's okay, again, I fetch that store. Otherwise, I throw an error. And then what that looks like down here is just your method, your ref for clearing the form, and there's your action for form action. And you'll notice it's on the action attribute, not on the on submit attribute. And and also look at the message form input and submit. No props passed to it because I don't need to, because this is not a controlled form. It's just native, or it's just the browser, which can make your life a lot easier in some cases. One thing I want to show too with that partial progressive enhancement I was talking about before is let me go over here. I'm just about done, Joshua, I promise. Let me go into network, that's what I want. And let me throttle things just a hair. We'll do fast 3G. And then what we're going to do is I'm going to refresh the page, and the second I can click in the input and type in and submit, I'm going to do it. Nothing's going to happen, but the second the page finishes rendering, something will happen. So we refresh, test. I clicked enter, nothing is happening. You can see the waterfall. It's fast 3G, so it's still loading. And there it is, test. And probably it'll fetch all of them. Oh, I cleared out the cache, so it's not caching between requests. But if we did that in the old form, refresh, blah, 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 and I clicked enter, I believe it'll just ultimately wipe the input. It will not be submitting anything. Oh, shoot, it did submit.
You still got the checkbox.
Oh, duh, sorry. To showcase that part, I need to go in and default it to be false. Thank you for that catch, Joshua. Take my word for it, though. It wasn't going to submit it because it's not using the new React wrapper around the native form attribute in order to support partial progressive enhancement. All right, let's get this wrapped up here. Thank you all for your patience. So I think the last API, I've talked about this briefly already, and there's not much more to mention here. So let's just kind of wrap that one up. Don't ignore the word synchronously. That's definitely a typo. It doesn't read all this stuff synchronously. You can pass to the new use API promises or contexts, which means and it will suspend as it's reading those. And it's now officially the preferred API over use context whenever you're accessing a context object from your application. It can also be called conditionally, which is really annoying because you cannot call hooks conditionally, right? And hooks start with the word use, but the API that is literally just the word use can be called conditionally. It's not a hook. And so it's helpful for people that are all about that prop drilling, is that, you can access context conditionally with it. You don't have to be worried so much about doing prop drilling to avoid conditional concerns. We used it earlier in that client component with a server action and a suspense boundary around it. So the client component was able to continue to render, and only that subcomponent that used use suspended while the promise passed to it from the server resolved. And then I think we're actually probably low on time, so I'm going to skip honorable mentions for now. And then scan this QR code if you want to talk to me more. Come hang. It'll open to a virtual business card. You can LinkedIn me. I am not rude. I will certainly accept, and we can certainly talk, and I would love it because I actually love React. Thank you for your time.
Do we have one question? We probably have time for one question before we kick over into the next talk.
Thanks, Joshua. Sorry.
Okay, we're good.
Oh, you had a question?
All right, we've got
Yeah.
it. Okay.
What's the, like, because on one project we were using React.js, we had to abandon it because it wasn't fast enough. So what kind of performance improvements do you see server side versus the?
Right. Good question. So it's a good question. I don't have any hard metrics for you, but for anecdotally speaking, you saw the example with the 3 different components and how they loaded in at different timings, the server component being the fastest. Mind you, that was a fairly simple component. The reason that's sort of tricky to answer is because there are different React 19 and 18 APIs that you can use to make the answer to that question even faster. Suspense will allow us to start streaming in content as it becomes ready. So React is capable of basically juggling multiple balls, like we'll render this, that's suspending, it can work on that, we'll continue to render this. But broad strokes, it's not going to be a life-changing amount, but I think if it's been a while since you or your team has looked at React in terms of its performance for your use case, after 19, which is in beta, once it comes into production release, I think you should take a look again. It might hit your needs. Yeah, thank you.
Sorry, Chris. You have to ask after. We're running out of time. We gotta be out of here at 4, so.
We got about 25 minutes.
You want to type in your email?
For your talk. Is that cool?
Yeah,
Kind of zip through it.
I'll make it fast.
Yes.
Sweet. We have David Nicholas, who's going to be speaking about TypeScript conditional types. So,
On your shirt collar.
On my shirt collar. Okay. Cool. Hello. How's everyone doing today? Thank you, Travis, for telling us about React 19. That was awesome. Can everyone hear me okay? I've never had a mic in my hand before, and this might be a mistake. But yeah, my name is David Nicholas. I also work for Bitovi with Travis. I'm actually based in Reno, which is 8 hours north of here if you live in Vegas. And apparently, if you're not from Vegas, you think it's about a 20-minute drive. Been running into that all week at ReactConf. But today I'm not here to talk about React. I'm actually here to talk about conditional types with TypeScript. I am a React developer, and I do a lot right now with micro frontends, React, and Next. However, one of my passions has always been TypeScript. I think TypeScript is a beautiful solution to typing the dynamic language that is JavaScript, and conditional types are my favorite feature. I got 25 minutes when I ran this originally, which was a couple days ago. I ran over an hour. This morning I ran it at 30, so I'm gonna try to cut down 5 more minutes, so we're gonna be moving fast. I'm gonna stop for questions when I can, but we're probably not gonna have a lot of discussion here, but we'll be out in the hallway and we can talk about things. Also, these sites, or these slides on a website, they're live, so you don't have to worry about taking pictures. I'll give everyone the URL for it at the end if you wanna go back and reference them. Cool. So with that, where are we actually going with this presentation? This is the roadmap. I want to start with the conversation around type systems. I think fundamentally, a lot of developers overlook how types are compared in TypeScript, and it's really important to have that background when you move into conditional types. After that, we're going to move into conditional types themselves. We'll look at the syntax and how to understand what extends means. We'll look at how conditional types behave with type unions, called the distributivity of conditional types. Additionally, we'll explore infer, which is a new keyword conditional types give you. We'll do some pro cons, and we'll talk about when you should be adding these to your code base. So without further ado, let's go ahead and jump directly into type systems. So type systems are how our data is labeled and organized within our code base, and we take a lot of advantage of it, right? That's how we know when something's a number and whether or not it's a string, and if we can concatenate them or not. And I think when it comes to the primitives, that's a very simple concept for us to wrap our heads around. A number isn't a string isn't a number, and so on. Where things get a little more complex are when we look at classes and objects. and trying to figure out, what is assignable to a different class or a similar class. If you were to take a second, you could probably come up with one of the two heuristics that most type systems use. The first of which is called nominal typing. Nominal typing focuses on the name of the class or the shape that you are creating. So in the example on the screen we have here, this isn't TypeScript, by the way, this is Swift. It's an iOS language. Any Swift fans in the chat? I guess you guys aren't a chat, but you know what I mean. All right, no Swift fans, it's all right. I don't blame you. But yeah, so up here we have a class cat, and it's a pretty simple one, right? We have a number of legs and a make sound function. And if we were to look at a dog with a similar shape, where we have a number of legs and a make sound function, very similar shape, different names. And if we create a variable called animal in this case, assign it to a dog, and then try to reassign it to a cat, we would run into a type error. And that's because cat is not a dog, and how Swift, that language, is making that type comparison is literally looking at the class name. CAT does not equal DOG. So that's one of the first ways that typing systems handle this more complex problem of comparing objects and shapes. The second, which is also the one TypeScript uses, is structural typing. Is anyone here familiar with structural typing, just right off rip? Awesome, one person, good, good. I always like getting to talk about it for the first time. So structural typing actually focuses on the shape or the structure of the type rather than its name. So up on the board here, we have a TypeScript setup this time, down with Swift. And it's the exact same setup, number of legs, make sound function. However, when we go ahead and go into our variable reassignment, we're actually not going to get an error. And that's because the two types up there have the exact same shape. So as far as TypeScript is concerned, a cat and a dog are the same thing. Or at least those ones on the screen are.
It's called duck typing also.
What was that?
Is this also called duck typing?
Sometimes, yeah. If you could also think about it like that, yeah. If it looks like a duck, walks like a duck, quacks like a duck, it's a duck. So structural typing often is kind of interchangeable with that duck typing.
It's another animal.
Yeah, just another animal, exactly. So I think this in and of itself is pretty intuitive, but TypeScript actually takes it one step further. Where instead of like a complete set of requirements, a TypeScript type is actually a minimum requirement. So up here we have the exact same setup. We have a number of legs, a make sound, number of legs and a make sound on the dog as well. But if we look there on line 8, we're adding an additional method. In this case, it's called scratch furniture. Our cat's decided to just cause us irreparable financial grief and tear up the couch. So our cat's a little different than our dog now. It has a scratch furniture function. And you might think that we'd get a type error here if we redo our assignment. However, we actually don't. And that's because animal, through TypeScript type inference, is being picked up as a dog. And for something to be a dog, it has to have a number of legs and a make sound function. Which if we look back at our cat, it does have a number of legs and a make sound function. Sure, it has that extra thing, but TypeScript doesn't care about that extra bit. So that's what I mean when I say TypeScript types are minimal. And in fact, it actually thinks that the cat, if we were to put this in a code editor, which I'm not going to do because we don't have time, if you put it into a code editor and you try to access scratch furniture on that animal variable, it's not going to show up. So might be kind of a weird place to start for a talk on conditional types, moving into the type system. However, we're going to see that conditional types really take advantage of the shape matching capability of TypeScript, so we need to understand how it is looking at these shapes. So any questions? Are we on the same page with this for now? Yes?
I have a question. So whenever you're defining your animal, does it matter which order you define your object first? Do you make it
Great question.
And it'll be like, oh, the minimum for a cat is this, therefore a dog is not a dog.
Great question. And the answer is, I forgot which way you said at the end, but yeah, if you assign the cat first and then to a dog, it would error. And that's because the dog does not fulfill the requirements of a cat because it doesn't have a scratch furniture function. Cool, great question. Any other questions on structural or nominal typing? Awesome, cool. Am I moving fast enough? Cool, yeah, so there's one other type system feature, I guess you would say, that I want to talk about before we kind of move into conditional types themselves, and that's the notion of top and bottom types. We are actually not going to use many things that come from top types in this talk. However, bottom types are a really weird thing, and I think the best way to talk about bottom types is in respect to top types. So that's why we're going to talk about top types. So what is a top type? Top type is the type that can be assigned to anything. If you're a TypeScript developer, you hear anything, chances are your mind's going to shoot right away to any, and you'd be correct. Fun fact, TypeScript actually has 2 top types, any and unknown. Kind of the similarity between the two, or the differences between the two is a little out of scope of this talk. The TLDR is any is a lot more freeform, unknown a lot more strict, but if you have a variable type anything, you can assign it to anything. So up on the board, we have that anything, it's assigned to a string, then an object and the number, and TypeScript is okay with all of those. So where top types contain all of the types, bottom types is assignable to nothing except itself. Great, what does that mean? Basically, TypeScript has one bottom type, which is never. And you should basically semantically be reading this in your head as this thing is never gonna happen. A common place where this happens inside of like your day-to-day app development is if you have a function that only throws, just like the one up on the screen. And how you should pretty much be reading this is function only throw is never going to return. And as we look at the implementation details, that's exactly what we see. Throwing is not returning. Excuse me. Other places it pops up, if you're a big switch fan, if you exhaust all your switch cases and move into your default block, you're going to run into never there because TypeScript knows that's never going to happen. So you can't assign anything to never except for never. Seems pretty useless if you ask me. When am I actually going to use this? And I think intuitively it does feel kind of useless. However, it gets really interesting when we look at combining it with other types. In particular, in our use case, we're going to be looking at it with unions. So what happens with a type union is when you put never in it, we should be reading the type union on the board, that type union with never, which is string or never, as string or something that's never ever going to happen. And since it's never ever going to happen, in your head you might be wondering, well, can we just remove it? And the answer to that is absolutely. And in fact, TypeScript takes it a step further and gets rid of it in our union for us. We'll see that type union with never is actually just a string. Cool. So that's going to be super handy for us when we actually start using conditional types with our type unions. We'll talk about that a little more with the distributivity of conditional types. Cool, so that's kind of our crash course on some of the type system background that we're going to put together. Before we move into conditional types, anyone have any questions on top and bottom types? No? Sweet, cool. So now we're at the meat of our presentation. How am I doing on time? Good enough? 19 minutes, all right, speed run, cool. Yeah, so we're gonna look at conditional types. And fundamentally, they behave exactly the same as conditional statements do in programming. When we look at the syntax too, it's gonna look very familiar if you're a programmer and have access to ternaries. I think many languages do, I can't name one that doesn't. But when we look at the syntax of conditional types, what we're gonna look at is, does some type extend some shape? If it does, we're gonna go down the truthy path, otherwise we're gonna go down the falsy path. When we're talking about extends, what we're really looking for is, does whatever we're comparing it against match the minimal requirements of that sun shape? Going back to the idea of structural typing. So that's a lot of big words and a lot of abstract thought. I think this is best illustrated through an example. Up there, we have a type user and we have a generic type has ID. Is everyone comfortable with generic types and generic syntax? Cool. Sweet, so that has ID is a conditional type, and it's basically saying, hey, does entity extend this ID string, or basically does it have an ID string is kind of the easy way to think about it. If it does, we're going to return true, otherwise false. And keep in mind, we're in type land right now. That's not the value true, that is the Boolean literal type true, and same with false. So if we were to pass our user into our has ID generic type, we do see that user has that ID of type string. So we are going to walk down the truthy path, which in this case is just going to spit out true for us. If we were to change ID to number or remove it from the user type altogether, we'd get false. Sweet. So yeah, this is the basic syntax of conditional types. Any questions or comments on it? Awesome. The speed run continues. Cool. So by themselves, they're interesting. But I think when we actually start looking at them with unions is when we see the real power of conditional types. And this is a section titled The Distributivity of Conditional Types. If people are looking at that word distributivity and having flashbacks to like 5th, 6th grade math and kind of panicking, that's the right feeling to have. That is the exact same concept. However, we're actually going to break it down so we can kind of get rid of that like weird mathy notation around it. Cool. So pretty much what happens is when given a union, conditional types will actually apply the conditional to each member of the union. And I think this is best illustrated by walking through an example together. Up there on the board, I have non-nullable. Unfortunately, this is the TypeScript 4 definition of non-nullable. When TypeScript 5 came out, they changed the definition from a conditional type to some wonky intersection that we don't have time to talk about. But what non-nullable does is it removes null or undefined from your types. So in our example, we have string or number is non-nullable, maybe string or number, where you can see string or number comes out and null and undefined are stripped out of that union. So how is TypeScript doing this? And I want to walk through kind of step by step how we can think about conditional types being applied to each member of this union. This isn't quite exactly how TypeScript does it. However, I think it's a really good mental model to illustrate this distributivity property that conditional types has. So starting with the basics, we have our type string or number. Set equal to non-nullable, maybe string or number. There's a lot of generic type syntax in there, so let's kind of strip some of that back. We know non-nullable is a conditional type, so it is going to distribute to each member of that maybe string or number union. So we could technically think about rewriting it as this, where we have non-nullable, string, number, or undefined, all in line with a union. From there, let's pull back our generic type syntax a little bit more, where we can just rewrite it as that kind of extended ternary. I'm not going to read that. That's a mess, and I trust everyone here can read a ternary. But evaluating each of those ternaries, we can see our new union comes out as string or number or never or never. Kind of seeing how we talked about bottom types before this, we know that never, when it's in a union, can pretty much be ripped out of there and completely ignored since it's never going to happen, leaving us with type string or number. And that's the distributivity of conditional types. It will apply the condition to each member of the union. Yeah, before we move on to the next thing, does anyone have any questions on this property? It's a really cool one, and TypeScript is great with this. Sweet. Awesome.
I guess I kind of have one.
Yeah. Go for it.
What does this save over just explicitly defining your type as a non-nullable or non-undefinable? Like, because this is like an implicit, once you do the union, then you have to do a diff and then remove all the types that you don't actually want, where you can just say like explicitly, I want these types only. Is that like you gain an advantage?
Sometimes. There's ways that, like, deriving types from other types is really kind of the name of the game when you're looking at the advanced TypeScript features. If you can do the just define it without the string or the null or undefined, you should go that route because it's simpler. But a lot of the times non-nullable or something else is used as almost like a way to derive types in the same way you derive values in a function. So like if you had a promise or something, we know that a lot of the times the pattern is, right, data can be undefined or the data. But if you have a function that is like, oh, I'm going to handle the undefined case and like it will never be undefined, rather than rewriting like that whole API type with the data being defined, you just use non-nullable to go ahead and make sure those things are defined.
Took the load off of the function, you put it on the controller with this.
Yeah, yeah.
Okay.
Cool. Awesome. Cool. So one last property of conditional types is you actually get access to a new keyword, which is infer. And the docs for infer are abysmal. I'm just going to let you know. It's the worst reading experience of my life. That's not true. That goes to the scarlet letter in 8th grade. But infer is a way for you to tell TypeScript, hey, if it does match this pattern, you should really know enough about it to tell me a little bit more information about this type and allow me to use it as a variable you create. Kind of weird, kind of pie in the sky type definition, but I think this is best illustrated through a couple examples. So we got two, and we're going to walk through the first one. We have that type unwrap promise, which takes the generic value, and basically we check if value extends a promise. Basically, hey, is this a promise? In TypeScript, if this is a promise, you should be able to tell me what it unwraps to. So I'm going to use the infer keyword and tell it to create a new variable called unwrapped. And if it matches that shape, I can use the unwrapped variable inside of my truthy path. So in this simple example, unwrapped is just going to be returned. So if we look at the example down below, we have unwrapped promise, where promise number is passed in, and we're getting promise out.
Sorry, what's wrapped?
Which one?
You need it for something to be wrapped, like a box or something.
Yeah, so sometimes promises are thought as like kind of like a box that anything can sit in. So when you unwrap a promise, it's just kind of like colloquialisms. You're kind of like pulling out whatever value that promise resolves to. So in a similar way, we can unwrap the promise at type time using infer.
Is it pointer? It's basically a pointer to not ready yet or the object.
It's a construct in JavaScript where it's used to represent those async values that haven't been fulfilled yet. Yeah. And also, like, infer with this kind of generic type syntax can be a little hard to understand sometimes. So I think this illustrates it just as well. Has everyone used template literal types in TypeScript? Probably not. It's kind of niche. But basically, it has the exact same syntax as string interpolation in JavaScript, where you can kind of see here we have these backticks and then the $sign and the curly braces. Basically, what it does in JavaScript, it does the same thing just at type time in TypeScript. So throwing it back a little ways, throw some Mean Girl quotes in there. We make a statement, I will keep you here all night. However, that is incredibly illegal, apparently. So we're actually going to amend our statement and say, I will actually keep you here until 4. And rather than using our heads and trying to figure out, how long we're actually going to keep people, we can actually use TypeScript to figure out how long with this additional how long utility type. So we have how long, takes a string, and pretty much what we're looking at is if string extends the shape, which is does the sentence basically begin with I will keep you here? If it does, TypeScript should be able to figure out what the rest is for us and give it to us as a variable that we can refer to it as later. So in the case of the statement type, after I will keep you here, we see that it's all night. So in the case of that type, rest will be all night. And in the case of the amendment type, or amended type, it will be till 4. So if we were to put those types in the code editor, which we definitely don't have time for at this point, we would see that those are the string literals that we're getting out of this conditional type. Sweet. So just a quick recap on conditional types. They behave like ternaries in JavaScript or TypeScript. They're just at type time. They distribute over unions, and you get access to a new keyword, infer. Just a note on infer, it is not something you can use everywhere in TypeScript. It is only in a conditional clause. Cool. How much time do I got, Josh? 8 minutes. That's not enough time for everything, so at this point, let's jump into a choose your own adventure. We can look at some pros of conditional types, some cons of conditional types, or when to use conditional types. Does anyone have a preference? When. Okay. The one that involves me skipping through the most slides. Awesome. Just gonna kind of... Okay, so after that great discussion of pro and cons of conditional types, if you're seeing this on YouTube, they actually, the footage got corrupted. It was great. We had a good discussion. But yeah, when should I use conditional types? The TLDR of the pro cons are they give you really good DX, but it comes at a pretty high cost. They're complicated. DX is developer experience. Good question. Yeah, sorry. So using conditional types, and I got kind of the most generic programming answer for you. When should I use these? It depends. However, that's a huge cop-out, and I'm not going to leave it hanging there. Instead, I actually want to break down the discussion into kind of 2 popular developer personas. We're seeing kind of a rise in, I guess, the development space or the JavaScript TypeScript space, which is your application code and your library code, which have very different types of requirements. So starting with the application code, when should I use this? In your app code? Very rarely. They add a lot of complexity to your code base, and chances are you don't need them. But if you are using them, chances are it's going to be in your service layer or in your utils folder. Your service layer and your utils folder have the highest level of type complexity in your project, just because that's where a lot of your generic logic resides. And if you are using conditional types, a TypeScript utility type is likely all you need. In the pros section, we skipped over, but a lot of our TypeScript utility types are using conditional types under the hood, namely that awaited and that return type, and that extract down and use at event. So we can use these types to go ahead and derive our logic from our different APIs that we're using. So in the case of use people, just kind of trying to pretend that use promise exists, we can imagine that use promise accepts a promise and just returns the resolved value. So in this case, people, and we'd return people. And in the same way that we can basically derive our return values in our JavaScript runtime, we can derive the return type at type time taking advantage of conditional types. So under the hood, awaited is a return type that basically does the same thing that unwrap promise did, that type we looked at. And then return type just gives you the return of whatever is there. Type of just turns get people from a value into a type. Similarly, our use at event, We are extracting, we can pretend that events is just a big old union of all of our different events that our application is going to be using, and we're just going to pull out the one that has type add. And then in our logic, we see we're doing the same thing except for using a filter. One thing that's kind of cool about this is we can actually, and one thing I like about it, you might not like it, it's definitely a personal taste thing, is you can actually kind of mirror your derivation logic in JavaScript at your type time. So we're extracting our events just like we're filtering them on that return.
So are types bad during runtime, or are they sort of compiled away?
They're compiled away. So TypeScript has this concept called erasure, which is basically they only exist until you do a build. Once you build, it's just pure JavaScript in the engine. So people sometimes jokingly call TypeScript the world's best VS Code extension because they actually never make it out to your production environment.
I mean, you could, right? You know, like enum types, it has to be.
Yeah, so enum types are kind of the weird exception. In fact, one of the reasons I really dislike enums, which got to make sure I don't go off on a tangent here, but basically enums are kind of the one area where TypeScript does exist at runtime because enums get compiled into an object. That way you can kind of reference them later and use them in the values of your code.
Compiled languages too.
Yeah.
A trick like nullable, where you can just use a zero because they can't be real quick.
Yeah, and that's one of the main kind of fundamental differences between TypeScript and a lot of those compiled languages is that type doesn't exist at runtime. So a lot of things like type reflection, you can't actually check the type of something at runtime. There are some things you can do like using instance of and those things, but like
compiled languages have erasure.
this one doesn't.
Well, not for enums, I'm saying for everything else.
Sorry, what?
Most compiled languages have erasure, just not for enums, because sometimes you can't erase enums.
Oh, gotcha. Okay. I'm not familiar with other compiled languages, so I'd love to talk more about those if you have some time afterwards. Awesome. Cool. Yeah. So getting back to application level code, not really going to use it all that much. Time check. Oh, sorry.
It's mostly for meta programming, right?
Meta program?
Yeah, programs that write other programs, templates.
Oh. Not sure. This is more like this is just typing JavaScript. So TypeScript is a superset of JavaScript that transpiles.
You could make that a parameter, and then, so you might have add or submit, or I don't know exactly what add is referring to. Something, and then it would write that code after, sort of automatically. Consider an array, right?
Mm-hmm.
It's a list of something.
Yes.
And it's homogeneous to types.
Mm-hmm.
So you write all this code not knowing what it's a list of, but then at runtime you create an object and then you tell it what it's a list of, like it's a list of ints.
So in JavaScript it doesn't care it's a list of like period.
You can't say it's a list of any.
Yeah, and and it's kind of weirder too because an array isn't even a struct in JavaScript, like JavaScript period. Arrays are just fancy objects, so everything's an object in JavaScript is kind of a running joke there. So yeah, it's a little different.
But at the TypeScript level, could you make a list of?
Yes, at the TypeScript level you can, and that's kind of where like the saying it's a superset of it. That exists at TypeScript time, but once you actually build your application, all of that goes away, and it's really just a developer helper tool to help you build out.
If all your code is TypeScript, then you'll never get something that you declared as a list of ints that has a string in it.
Correct, and except for when you like reach the edges of TypeScript and you start lying to it at times. Things like API requests are a good example of that, and that's one of the reasons you should never use as, because as is kind of taking over. It's not necessarily a type cast, but that's the right way to think about it. It's a type assertion, basically telling you, hey, you're wrong. TypeScript has a couple guardrails. Travis, can I get your password? TypeScript has a couple guide rails to try to help you not do that, but there are still ways around those safety nets. Really at your service levels where you run into a lot of those, or if you wrote too restrictive of a type, a lot of casting happens. We also didn't see it, but in some of the cons, the inference mechanisms TypeScript has a real hard time with conditional types, and it isn't able to see that like this logic matches the conditional when you're actually implementing the functions. Yeah. But yeah, great question. How much time I got, Josh?
Like 60 seconds.
60 seconds, great. All right, last slide. As soon as Travis figures this out, I'm going to kind of just talk and hope for the best. Library level code, there's a lot of different ways we can use conditional types, and at the end of the day, this is where you are going to find conditional types being applied rigorously. You can do a lot of cool things with it, like applying type constraints. You can actually figure out things that you can only figure out at runtime using conditional types at type time. Additionally, it helps us simplify complex overloads. It gives us the capabilities of doing advanced type mapping, which has a really cool example I wish we could walk through. And it allows us to distill our types, kind of like we were saying with non-nullable, but apply it in a more advanced pattern. Cool. I think that's all we have time for today. I was given 60 seconds, but the projector hates me.
Projector does hate you.
Thank you. Yeah. I have a QR code too. Let's talk on, I think it's to LinkedIn. That's the right networking thing, right? If you want to do Twitter X. Yeah, let's do that. Love to hear more about the compiled language questions you were talking about. But yeah, if anyone else wants to talk about things as well, I'll be here for a little bit. And if not, Travis, can you turn the computer around at the thank you for your time slide?
Oh, absolutely.
I'm going to walk around, and if you do want to talk, you got to get out of here. Totally get it.
Is there a website that, I mean, because
Yeah.
can you send me the link? Because on the meetup.com, I can post the slides there as well.
Yeah.
And then we can also get that on the YouTube link as well.
Okay,
So
awesome.
people can actually grab the slides and view it in more detail.
Yeah, so all of the slides are online. This is the URL. I'll hold it up to the computer too, the camera too. But if people are interested in talking, I'm always interested in talking and learning new things. Yeah, thank you guys. It's been fun.
Thank you.
No, this is mine now.
Can you give it to Doc?
Okay, so that's it. That's Vegas Programmers. Thank you very much. Another round of applause for Travis and David for giving the talks. I really appreciate them coming out and volunteering to do this. If you do have a talk you would like to do, feel free to grab a business card here on your way out, grab a free sticker. And typically we head over to Taverna and, talk shop. So we'll see you there. Thank you, everybody.